And then last, Phil Northcott. Phil is the founder and CEO of Sea Change Labs and is the co-creator of EC3, which many of you know, which is the embodied carbon and construction calculator tool. Phil has been a leader in research and development for over 22 years, first in the telecommunications field, then with solid state drives, and now a leader in R&D with climate change. Phil holds a Bachelor of Applied Science and Engineering from Simon Fraser University, holds 22 US patents, and lives in Coquitlam, British Columbia. In addition to continually adding features to EC3 and working to harmonize digital EPDs globally, Phil somehow finds time to have the patience to answer the most technical of questions and seems to have an endless supply of dad jokes.
Quick reminder, I lead Sea Change Labs. We're a climate change focused cloud software company. Our goal is to bring the best of cloud compute to the fight against climate change. Most of our work is done within the NGO Building Transparency, which came out of the CLF and was has a wonderful board of directors that you can read all about on our webpage. And Building Transparency is one of Building Transparency's core tools is the EC3 tool, which is a combination of a few things. First, it's a very large database of every environmental product declaration we've been able to round up, organized by category and searchable not only by environmental product declaration type measures, but by performance measures, things like 28-day compressive strength, or of course other curing, of course, strength at other time periods, exposure class, and other stuff that you would need to know in order to make some kind of a, I won't claim apples to apples comparison, but maybe not apples to cucumbers. When we search the database, we're now able to give you a range of what's possible, give you an idea that about 80% of concretes in this category are worse than 376.3 kilos of CO2 per cubic meter, but that means that 20% of them are better. You should be able to hit this target if you aim to it. It also gives you a conservative estimate. So 80% are better than 550.2. Gives you an idea of the scope in terms of how much reduction you can get. So there's a whole set of search tools that are different for every material category and allow you to find actually appropriate products that meet your specs. A second big part of it is a building planner. It's basically a cost model, like a contractor's cost model, but for embodied carbon instead of dollars. And for example, I'm opening this. This is a real project. This is an anonymized project donated by one of our partners. And you can see that they've entered in and searched they've entered in the quantities. They've searched for the properties of each one. And when they were done, they were able to, for example, view where the largest savings are and how it all rolls up into a building. A third part is the database itself. You can see kind of where environmental product declarations are. In fact, if you want to illustrate the impact of automation on this process, the best way to do is to look at the number of EPDs by category. And you can see that with Chris's assistance, there are more concretes than everything else put together. It's so many more that we couldn't even put it on the same graph. And there's no reason why this can't scale to lots of other categories as long as we capture and verify the formulas for generating the EPDs rather than attempting to capture the EPDs themselves. Now, historically, as Chris was pointing out to you, EPDs have looked a little bit like this. You know, they're often captured as a Word document. They're very carefully put together as a, in many ways, a marketing document. But they're all different. You know, this is one from Milliken, but you know, if you did one from Armstrong, you know, this is also a beautiful document, but it's very different. The data is all in different places, and it's not really possible to do comparisons in bulk using these. You can't, for example, simply do this. Compare a group of manufacturers and understand the embodied carbon of each one. Whereas if you digitize them, you know, you can even pick your region, search, you can get currently valid EPDs. And in just a few moments, you can see how different manufacturers line up. You can find your, you can find a level at which, for example, there's guaranteed to be at least 3 vendors. You can do all the sorts of things you would need to do in a procurement in order to do bid leveling and make selections. So in order to get from this point to an actual database, we have largely been doing a combination of text interpretation using a little bit of AI and a lot of elbow grease, and just smart scripts that we write up to try to understand each of these formats and digitize them for you. But we all know that's not scalable. It doesn't make a lot of sense to do these LCA simulations, extract them, carefully format them for a human, and then have me bring them back into a digital format for consumption by a procurement team. So what we've been working on with a whole community of people, including Chris, is a digital first strategy where, you know, when you create a new EPD, you know, it actually starts as a, you know, it actually starts as a digital object, and you would actually capture everything about it, including its various impact forms and so on, in a digital format with the uncertainty captured, with the system boundaries captured and so on, location, and who exactly is verifying the system. And that is a project we're calling OpenEPD. It's meant to be an open standard that anyone can use without charge. It's based on an industry standard called OpenAPI, which is developed by the open source community to get tools to talk to each other. It's the kind of thing that allows, for example, Zoom to talk to Google Calendar, Zoom to talk to Outlook, Calendly to talk to both of those things, Box to talk to like Box.com to talk to EC3. This is a way for databases to talk to each other, including Chris's UL, SCS Global, International, EPD system, and so on, and exchange this data automatically and immediately. We think that is the correct direction in order to bring down the cost of environmental product declarations to make sure that they are ubiquitous. The last thing I'd like to say is that as for manufacturers, one of the key things they need to be able to do is control where their data, understand where their data is, and adjust it. And I would like to encourage any of you who aren't already to sign up for EC3 if you're a manufacturer, and then you can do things like manage your organization, manage the people who have rights, manage your plants and your EPDs. Because and as a manufacturer, although you can't edit any of the sustainability data, you are the people who know the most about how your product is actually used, and that's the kind of thing that we would very much like you to take control over.